Greetings, class. Today we begin Lecture 2, Session 1, Information Technology Infrastructure. If you recall, we studied Information Technology Infrastructure and we went over the 7 categories of infrastructure. It is the hardware platforms, the operating systems platforms, enterprise software applications, database management and storage, networking, telecommunications platforms, internet platforms, consulting, and system integration services. I want to discuss with you things that not quite covered in the textbook that we studied, which is the services. Services include systems that a firm can provide to its customers, suppliers, employees, and business partners. So let me explain why that is important, that we have to cover that. As technology advances, the types of hardware and software become more available. It becomes more critical for the firm to focus on the services that a firm can provide to its customers, suppliers, employees, and business partners. Note that this type of services is not exactly the same as the integration services we identified above. Software integration means ensuring the new infrastructure works with the firm's older, so-called legacy systems, and ensuring the new elements of the infrastructure work with one another. Legacy systems are generally older transactional processing systems created for mainframe computers that continue to be used to avoid the high cost of replacing or redesigning them. Replacing these systems is cost prohibitive and generally not necessary if the older systems can be integrated into a contemporary infrastructure. So that is the integration services, which is totally different from the kind of services that we are discussing next. Okay. So to round out the list of IT infrastructure components, you need to add the following services. Computing services provide platforms that ensure a coherent digital environment. Telecommunications services determine appropriate data, voice, and video that connect employees, customers, and suppliers. Data management services not just store but manage massive amounts of corporate data and make it available for users to work with. Application software services, enterprise resource planning, customer relationship management, supply chain management, and knowledge management systems. Physical facility management services, physical installation of computing, telecommunications, and data management services. IT management services plan and develop infrastructures, coordinate IT services among business units, account for IT expenditure, and provide project management services. IT standards services developed policies that ensure interoperability of all IT infrastructure components. IT education services train employees to properly use IT investments and educate managers about planning for and managing the investments. IT research and development services research future IT projects and investments. We want to review the evolution of corporate IT infrastructure in order to offer some insight into where we might be headed. The first era is called the general purpose mainframe and mini computer era, starting in 1959. The mainframe era began with highly centralized computing of networks of terminals concentrated in the computing department, whereas early models contained proprietary software and data. Today's mainframes are able to process a wide variety of software and data. It's interesting to note that IBM began this era and remains the sole supplier of mainframe computing. Although the experts and pundits predicted the death of mainframes in the mid-80s, they have evolved and remain a strong, viable component in many IT infrastructures because of their ability to store and process huge amount of data and transmissions. Mini computers helped usher in the concept of decentralized computing. Personal computer era from 1981 to present. It's interesting to note that the advance developed for personal computers in the home have given rise to much of the advance in corporate computing in the last 25 years. As the home user became more comfortable with using computers and more applications were developed for personal computers, employees demanded increased use of computers in the workplace. Although the Wintel PC standard has dominated in this area, open source software is starting to put a big dent into that stronghold. Client-server era began in 1983 as the desktop and laptop personal computers became more powerful and cheaper. Businesses began to use them to replace mini computers and some mainframe computers by networking them together. Think of an octopus with the body representing the server and the tentacles representing the clients. At the heart of every network is a server. It can be a mainframe, a mid-range, a mini computer, a workstation, or a personal computer. It's where some of the data, application software, and other instructions are stored that network users need in order to communicate with and process transactions on the network. Large companies use a multi-tiered client-server architecture that has several different levels of servers. At the top tier, we have web servers. As the name implies, it provides web pages to the users. The client computer is the node on the network that users use to access and process transactions and data through the network. Rather than one server trying to do it all, each server is assigned a specific task on the application server. Dividing tasks among the multi-servers allows faster, more efficient responses that cost a business less to process than a mainframe would, or one computer trying to do it all. Enterprise computing era from 1992 to present. Perhaps no other area has seen the explosive growth in functionality and popularity as this era. The problems created by proprietary closed systems are being solved by the standards and open source software created in this era. The promise of truly integrated hardware, software, and services is coming true with the technological advances in the last 15 years. On the other hand, the promises of delivering critical business information painlessly and seamlessly across all organizational levels are made all the more difficult to meet because of the ever-changing landscape of technology products and services. Cloud and mobile computing era 2000 to present. It almost seems as though we've come full circle with the concept of cloud computing. This model of computing relies on the massive computing centers owned by the likes of Google, IBM, Microsoft, and even Amazon. What is Google Cloud? Is a network made of hundreds of thousands, or by some estimates 1 million cheap servers, each not much more powerful than the PCs we have in our homes. It stores staggering amounts of data, including numerous copies of the World Wide Web. This makes search faster, helping ferret out answers to billions of queries in a fraction of the second. Unlike many traditional supercomputers, Google's systems never ages. When its individual pieces die, usually after about 3 years, engineers plug them out and replace them with new, faster boxes. This means the cloud generates as it grows, almost like a living thing. To summarize, there are 7 major components of a modern IT infrastructure: hardware platforms, operating systems platforms, enterprise software applications, data management and storage, networking telecommunications platforms, internet platforms, and consulting and system integration services. We added another component, services, which is a holistic offering of all of the above. With the advance of the internet, companies have to change their business models somewhat if they are going to maintain their share of the market and stay competitive in the marketplace. In today's business world, businesses can gain a competitive advantage over the competition by compiling useful information that is collected and stored in their databases. The quality needs to be just as important as the data itself. The advent of the internet and other informational resource tools make the speed to which management has access to information vital to the success of the company. In fact, the information that businesses have access to is, in many cases, a more important resource than working capital, materials, and human resources necessary for production. It is also vital that organizations have information systems that are capable of compiling those datasets and organizing them in ways that is useful for employees, suppliers, and customers. Cloud computing is a technology that puts your entire computing infrastructure in both hardware and software applications online. It uses the internet, remote central servers to maintain data and applications. Gmail, Yahoo Mail, Facebook, Hotmail, etc. are all the most basic and widely used examples of cloud computing. Businesses need to be cognizant to and pay close attention to the development of mobile applications as mobile devices continue to evolve. In today's world, just about everyone owns a cell phone or has access to one. Businesses need to think about their target users and what their needs and wants are. Are they a more typical type of customers that is interested in the latest apps, or are they the type that prefer to have something that is user friendly? These are important aspects of a company to ask themselves when designing the mobile device for the end users, because they don't want to miss out on any potential sales due to customer frustration, for example. Another aspect where organizations go through great lengths is how they take the efforts to collect and assimilate data on their suppliers and customers. They have done a great job on integrating and using the data in the past. And as the company matures, that need to fulfill organizations go through great length to collect and assimilate the data on the suppliers and customers. They have done a great job of integrating and using data in the past, and as the company matures, they need to fully use that data to take advantage of the new products and the identification of marketplaces which to proceed. As data becomes an asset that is vital to the survival and growth of a company, governance and administrations have to be properly conducted to protect the asset its use. Data administration deals with the proper management of information in the organization. It deals with data availability, capacity, proper control and security of data. It also deals with immediate issues at an operational level. Data governance ensures, on the other hand, that the organization does not mishandle the information and that the organization adheres to all regulations and legal requirements such as privacy and security of data. Data governance aids in creating effective methodologies, approaches, and techniques in an organization. This includes policies and procedures to ensure that data is available and relevant, having a secure data system, and having dependability. Let's take a look at how data is being used in management information systems, decision support systems, and enterprise support systems because all of them lead us to the next topic, which is the business intelligence infrastructure. You can refer to chapter 2 of the textbook for an in-depth explanation of MIS, DSS, and EIS. Management Information Systems, or MIS, serves middle management. MIS provide middle managers with reports on the organization's current performance. This information is used to monitor and control the business and predict future performance. MIS summarize and report on the company's basic operation using data supplied by transaction processing systems. The basic transaction data from TPS are compressed and usually presented in reports that are produced on a regular schedule. Today, many of these reports are delivered online. So take a look at figure 2.3. It shows how a typical MIS transforms transaction level data from inventory, production, and accounting into MIS files that are used to provide managers with the reports. Figure 2.4 shows a sample report from this system. MIS typically provide answers to routine questions that have been specified in advance and have predefined procedures for answering them. For example, MIS reports might list the total pounds of lettuce used this quarter by a fast food chain or a sale trending report. Other type of analytic systems support more non-routine decision making. Decision support systems, or DSS, focus on problems that are unique and rapidly changing, for which the procedure for arriving at a solution might not be fully predefined in advance. They try to answer what if questions such as these. What would be the impact on production schedules if we were to double sales in the month of December? What would happen if our return on investment in a factory schedule were delayed for 6 months? Although DSS use internal information from TPS and MIS, they often bring in information from external sources, such as current stock prices or product prices of competitors. These systems are employed by super user managers and business analysts who want to use sophisticated analytics and models to analyze data. A voyage estimating system calculates financial and technical voyage details. Financial calculations include ship time costs, freight rates for various types of cargo, and port expenses. Technical details include a myriad of factors such as ship cargo, capacity, speed, port distance, fuel and water consumption, and loading patterns. The system can answer questions such as the following: giving a customer delivery schedule and an offered freight rate, which vessel should be assigned at what rate to maximize profits? What is the optimum speed at which a particular vessel can optimize its profit and still meet its delivery schedule? What is the optimal loading pattern for the ship bound for the U.S. coast from Malaysia? So figure 2.5 illustrates the DSS built for this company. The system operates on a powerful desktop personal computer, providing a system of menus that makes it easy for users to enter data or obtain information. Executive Support Systems (ESS) help senior management make strategic decisions. They address non-routine decisions requiring judgment, evaluation, and insight because there is no agreed on procedure for arriving at a solution. ESS present graphs and data from many sources through an interface that is easy for senior managers to use. Often, the information is delivered to senior executives through a portal which use a web interface to present integrated personalized business content. ESS are designed to incorporate data about external events such as new tax laws or competitors, but they also draw summarized information from internal MIS and DSS. They filter, compress, and track critical data, displaying the data of greatest importance to senior managers. Dashboard is used to display real-time data with drill-down capability to much finer details. So, class, we have just talked about the components of modern IT infrastructure and its evolution through time. In order to create insightful and actionable business information, we need tools, technologies, applications, and practices to collect, integrate, and make intelligent our data. The results from business intelligence and analytics are delivered to managers and employees in a variety of ways, depending on what they need to know to perform their jobs. MIS, DSS, and ESS, which we introduced in Chapter 2, deliver information and knowledge to different people and levels in the firm: operational employees, middle managers, and senior executives. In the past, these systems could not share data and operate as independent systems. Today, one suite of hardware and software tools in the form of a business intelligence and analytics package is able to integrate all of this information and bring it to managers' desktop or mobile platforms. So, class, we have just talked about the components of modern IT infrastructure and its evolution through time. In order to create insightful and actionable business information, we need tools, technologies, applications, and practices to collect, integrate, and make intelligent our data. Lecture 2, Session 2, Business Intelligence Platform. Business intelligence is a contemporary term for data and software tools for organizing, analyzing, and providing access to data to help managers and other enterprise users make more informed decisions. Business intelligence addresses the decision-making needs for all levels of management. This section provides a brief introduction to business intelligence platform. Before discussing business intelligence, we need to discuss two important topics, the middleware and the intelligence business models. Middleware is the link between two or more systems. A middleware plays many roles. It facilitates communication between front-end systems. It manages connectivity to the back-end by creating connecting pool to provide access to the database. It implements logic-based functionality based on the request from the client so that the data returned can be further conditioned. There can be unlimited logic programmed into the middleware to fine-tune the results presented back to the client. Middleware can also scale vertically and horizontally and act as a load balancer. Middleware is sometimes called plumbing because it connects data systems and databases together so that information may be passed along the pipe. Another important benefit of the middleware is that it also secures access to the back-end systems. IBM classifies middleware tools into three main categories: data management middleware, communication middleware, and platform middleware. Examples for data management middleware are Open Database Connectivity or ODBC and Java Database Connectivity or JDBC. Communications middleware includes Java Messaging Services or JMS and web services based on Simple Object-Oriented Protocol or SOAP. Platform middleware is well known today as application servers like J2EE or .NET Framework. Vendors such as IBM, Red Hat, Oracle Corporation, and Microsoft are some of the vendors that provide middleware software. The most common used middleware solutions include Red Hat JBoss Enterprise Application Platform or EAP, IBM WebSphere, and Oracle WebLogic. All these examples of middleware enable network-based interactions between two or more systems. One example of the middleware solution is Oracle Fusion Middleware Solutions. It can be used to support complex and distributed business software applications. It includes web servers, application servers, and content management. The Oracle Fusion middleware is a collection of standards-based software that also includes many tools and services such as Java EE compliant environment and other developer tools. In regards to security, please note that a middleware is generally unable to gain access to the backend unless it has the security lock-in credential to do so. In some instances, there could be an explicit connection to the database at runtime. The lock-in is usually defined as a connection string in the middleware source code or a special included file to be called anytime a trip to database is required. It is the same reason why middleware source code must be protected from logical SQL injection and physical compromises. Decision-making model. A decision model is not a physical model of how business logic is to be implemented in a specific technology. Also, it is not a model for how business logic is to be communicated through procedure manuals or training materials. Instead, it is an intellectual template for the full and rigorous specification of that logic. A decision model can be translated into any format and is mostly easily referenced by humans. Likewise, it can be translated into one or more targeted technologies through appropriate design methodologies. Decision modeling applies three basic concepts to produce decision models or decision requirement models. These models are network of decisions, input data or information objects, and knowledge sources or presentations. Decision model can be applied into every industry or field. Here are a few decision models that are widely used: the SWOT analysis, decision matrix analysis, decision trees, or Pareto analysis. Another model that is widely used is the simple six-step model of rational decision making. The 6 steps are: define the problem, identify the decision criteria, allocate weights to the criteria, develop the alternatives, evaluate the alternatives, and select the best alternatives. Business intelligence platform. Data warehouse. Data warehouse is one of the critical components of BI because the data warehouse takes information from any and all systems to form information for the decision maker. When selecting data warehouse vendor, it is important to look at several important criteria in order to make the right decision for your firm. The size of the organization, resources, and performance needs for the firm play an important role in the type of data warehouse product to be selected. Data warehouse should be deployed depending on the size of the company. For a large firm with many employees and resources to manage the database, they can deploy multiple data warehouse platforms which allow for all traditional queries to be processed by the RDBMS, while the non-traditional queries to be processed by other means for other DBMS. For firms with very little or no IT resources, they should consider using a data warehouse appliance or a cloud-based data warehouse as a service. Big data. Hadoop emerged primarily to handle unstructured big data. Big data is not necessarily big in volume only, because your data warehouse can certainly span multiple petabytes of data. Big data is usually unstructured or semi-unstructured data, meaning not structured in a way that is stored and processed easily in a relational database, more specifically SQL. Big data is comprised of structured or unstructured data derived from multiple sources like web logs, RFIDs, GPS systems, sensor networks, social networks, internet-based search documents, internet search indexes, detailed call records, etc. Using big data from these sources will help. With the help of data analytics tools, database management and decision making can benefit organizations looking to make better decisions. If you look at customer case studies from Teradata and MarkLogic, depending on the particular case studies reviewed, you will notice that big data involve volumes of data, speed, timeliness, and the need for automation. Data mining is a part of the business analytics of BI. Data mining is a process through which previously unknown patterns in data is discovered. In the technical terms, data mining analyzes enormous amount of data in various dimensions and different perspectives to search for hidden patterns. Data mining can also help classifying and grouping the data and identifying relationships. Data remining process consists of different steps including data extraction, data transformation, and loading of data onto the data warehouse system, managing data in a multidimensional database system, providing access to business analysts and IT experts, analyzing the data by tools, and presenting the data in a useful format, such as a graph or table. The objectives of data mining are achieved by identifying relationships using classes, clusters, associations, and sequential patterns by the use of statistical analysis, machine learning, and neural networks. Data mining brings many benefits to business. It helps businesses discovering knowledge, predicting future trends, understanding customers' preferences and purchase habits, and conducting a constructive market analysis. Data mining helps enterprise to make informed business decisions, enhance business intelligence, thereby improving the company's revenue and reducing cost overheads. Sentiment analysis or opinion mining. Sentiment analysis, also known as opinion mining, refers to the process using text analytics to mine various sources of data for opinions of certain targeted groups of people. The objective of sentiment analysis is to understand the attitudes, opinions, and emotions of people toward an entity, an event, or a topic. Often, sentiment analysis is done on the data that is collected from the internet, from different devices, and from various social media platforms such as Facebook and Twitter. The ability to extract insights from social data is a practice that is being widely adopted by organizations across the world. The applications of sentiment analysis are broad and powerful from business perspective, such as knowing the voice of the customer, brand management, or employees, to political perspective like the voice of the voters. Stream analytics. Stream analytics refers to the process of extracting the actionable information from continuously flowing or streaming data. Stream analytics are currently applied in many fields including e-commerce, telecommunications, power industry, financial service, health science, or law enforcement and securities. In e-commerce, for example, at Amazon, every page visit, every product looked at, every search conducted, and every click made is recorded and analyzed to maximize the value gained from a customer's visit. Many Amazon Web Services customers use streaming data to gain real-time insight into customer activity and immediate business trends. In summary, this lecture only reviews some aspects of BI and BI infrastructure. Please refer to the textbook and other tutorial materials for more details. The takeaway point for this is that information is becoming as important a business resource as money, material, and people. Even though a company compiles millions of pieces of data, doesn't mean it can produce information that its employees, suppliers, and customers can use. So businesses are realizing the competitive advantage they can gain by compiling useful information, not just data. Hello class. In this session 3, we are going to talk a little bit about research and the importance of citation. It is important to cite sources you used in your research and cite them correctly for several reasons. To show your reader that you've done proper research by listing sources you used to get your information. To be a responsible scholar by giving credit to other researchers and acknowledging their ideas and accomplishments. To avoid plagiarism by quoting words and ideas used by other authors. To allow your reader to track down the sources you used by citing them accurately in your paper by way of footnotes, bibliography, or references. You must cite facts, figures, ideas, or other information that is not common knowledge. Ideas, words, theories, or exact language that another person used in other publications. Publications that must be cited include books, book chapters, articles, web pages, theses, etc. Another person's extract words should be quoted and cited to show proper credit. When in doubt, be safe and cite your source. Be careful. Sometimes it's hard to tell if it is plagiarism or poor scholarship. Plagiarism occurs when you borrow another's words or ideas and do not acknowledge that you have done so. CSUs use SafeAssign to verify the authorship of your work. Many other tools such as SafeAssign exist, such as Turnitin and Grammarly. You need citation in both places. They are referenced and in-text citations. The format of citation is different depending on whether it is within the body of your paper or in a references page at the end of your paper, and you need both. Formatting style. There are many formatting styles. There is ACS style, there is IEEE style, APA style, and MLA style. CSU requires APA formatting. CSU requires APA formatting. You must always cite your sources, whether the requirement is explicit or implicit. Here is an explicit requirement. You must check to find out what is the minimum number of sources to use for your literature review. I think the presentation requires that you have to have at least 2 sources. Every source used is peer-reviewed or academic in nature, so you must avoid unreliable sources such as blogs or vendors advertise. You must follow the APA formatting. Citations and reference must match. My advice is to cite APA using MS Word. You can find many tutorials for this feature. Also, Purdue Online Writing Lab is the most used resource. I go there all the time. So, good luck with your papers. See you in class. My advice is to cite APA using MS Word. You can find many tutorials for this feature. Also, Purdue Online